Okay, so today we're going to be finding an explicit solution for Pmax. So you've already seen this if you've seen my previous video where we solved for Pmax, but this time we're gonna take the more nuanced expected utility comparison. So I'll quickly explain the story. 0.6 is the probability that you get into an accident. 1 less Q is the probability that the insurance company insures in total against the accident, where 10,000 is your wealth, less 6,400 is the damage. That's the premium payment, and that is the full coverage. All to the power of 1/2, which is your risk aversion, plus Q, which is the probability that the insurance company does not insure. So 10,000 less the damage, less the premium, because you're still going to pay it either way, but this time you're not getting the 6,400 back. All to the power of 1/2, and then plus 0.4, which is the probability that no accident happens. 10,000 less the premium. In every single case, you're paying the premium. All to the power of 1/2 equals 76, which is your expected utility of just not buying insurance. So how do we find the Pmax? So first we should clean this up. Okay, so I've cleaned it up a bit. I cleaned up here because it's just going to be 10,000 less the premium. This has been cleaned up, and then I factored in the 0.6 into each term here. It's a little bit more clean, and now we're going to bring out 10,000 less P to the power of 1/2 on these two terms. So I'm going to do that now. This is our next line here. So I made this theta and I moved him over to the other side. And now we're going to square both sides. So just as a reminder, because sometimes I'll forget this rule, I'm going to write it down here. Like I said, there's no shame in working through it slowly. So that's what I'm doing now. I've squared both sides. Now I'm just going to work through this line here. Okay, so it's been cleaned up pretty well. Theta, I forgot a 0. Theta times 10,000 less P equals 5,776 less 91.2 Q times 3,600 less P to the power of 1/2 plus 0.36 Q squared times 3,600 less P. This is going to look quite familiar because it's quadratic, or it's going to become more obvious that it is very soon. All right, so I've introduced y. So let y equal 3,600 less p to the power of 1/2. So y squared will be 3,600 less p. So, and 10,000 less p equals y squared plus 6,400. So now we can rewrite some things. This is this interaction right here. This is y, and this is y squared. Now we're gonna rearrange, and then we're gonna have our solution very soon. It's kind of exciting. Okay, so I'll show you what I did here. We're gonna start somewhere up here, and then we're gonna make our way down, all the way down to where we find our Pmax, because I recognize there's a lot going on here. I kind of wish I had a bigger board. So, we are trying to put this equation all up here into a more digestible quadratic problem, okay? So, we are taking steps to make it more simple. We introduce theta, and then we introduce y. We insert y, or we rewrite the equation so it looks quadratic. So ay squared plus by plus c equals 0, which is exactly what we have here, where our ay squared is theta less 0.36 q squared times y squared. Our by is 91.2 qy, and our c is 6400 theta less 5776. Okay, this is equal to 0. And then this is the quadratic solve for that. Or this equals y. Give me a sec. Yeah, sorry. So this equals our y right here. We already have our y defined. So therefore our p, which is equal to our Pmax, is equal to 3600 less y star squared. And that is enough. That is the explicit solution for Pmax with this story right here. Your job is to reorganize it in a way that it can be expressed as a quadratic, and then to isolate p, which is what we did here. We just put p on the one side. So wasn't too difficult storytelling, but this one is definitely a bit more math heavy, so I hope this helps. I wrote down all the little rules that you may have forgotten. I know I did. So this one's pretty important. The a less b squared equals a squared less 2ab plus b squared. Sometimes I forget those, you know, and there's no shame in that. I certainly forgot these. So it's important to sometimes get a little refresher on your math skills, especially when they're not so good to start out with, which is exactly where I'm at. But all right, I hope this has been informative. We have our Pmax.